My name is Steve Boyer. I teach Earth Science and Geology at Scarsdale High School. This past fall, I helped coordinate a course called The Quest for U.S. Energy Independence.
The topic of energy resources and sustainability is growing in importance and relevant across the grades. This information, however, is often confusing, and teachers need background data on the origin, location, and quantity of fossil fuel resources as they increasingly incorporate the critical study of energy into their curriculum. We wanted the teachers of the course to be able to understand questions such as, why are oil companies drilling at the far edges of technology beneath a mile of water and 3 miles of earth to bring new resources to market? Why did Japan build nuclear plants on a tsunami-susceptible island? How will continued uprisings in the Arab world affect the price of oil and the global economic recovery? We hope that teachers will be able to incorporate these and other energy-related issues into their curriculum.
So I took the STI class, Quest for U.S. Energy Independence, and what I took out of it immediately to bring back to my classes was how graphs can be either partially or wholly misleading. And I brought it back into my calculus classroom where we're recording data on a pretty regular basis these days, and how these bright, mathematically astute kids, and myself included, will sometimes look at graphs and just believe that this is exactly an impartial graph, but in actuality, the author may have an agenda. So I went through and collected a number of different graphs that were either completely wrong or misleading, and talked about some guiding questions of how you might interpret a graph and think about what the author's intentions were, or is the scale correct? And we looked at some graphs and found out that upon first glance, perhaps it looked perfectly fine, but you realize that the percentage in the circle graph actually doesn't add to 100, or the pieces are not in the proportion that they ought to be, or a scale is actually not uniform on both the x and the y-axis. And this led to some great discussions, because if you're watching TV or if you're reading a newspaper quickly, you may not think that it is, you just would assume that it is impartial, and in fact it may not be. So you want to take your mathematical reasoning out of the math classroom and into your life on a more regular basis. And then the second part of what we did is I was given a great resource of data, which I then brought back to the class, where the kids were finding the area under curves using integration. And I want to, as much as possible, bring in some real data for them so that the meaning of what they're finding is significant to them. So we did that. We looked at line graphs that represented the production of oil in the United States or in the world, and they found the area under the curve, and then what is the meaning of the area under the curve, and there was some unit conversion that they needed to do, which again I think is just a great tool. So we had a wonderful class.